Hello and welcome friend. In this video we discuss about the hyperbolic functions. Friend, you are familiar with the trigonometric functions. Likewise, there are another type of functions which we call as a hyperbolic functions. The hyperbolic functions are differentiated by substituting h in the in trigonometric symbols which we use, like the sine of theta. So instead of sine of theta, when we write it as a sine h theta, that means it is an hyperbolic functions. So similar to the trigonometric functions, we have a notations of hyperbolic functions. Hyperbolic functions are sine hx, sine hx, cos hx, tan hx, cot hx, sec hx and cosec hx. These are the hyperbolic functions. Now we define the definitions of hyperbolic functions. Sine hx equal to e raised to x minus e raised to minus x divided by 2. Cos hx equal to e raised to x plus e raised to minus x divided by 2. And as usual, tan hx equal to sin hx divided by cos hx equal to e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x. And cot hx equal to cos hx divided by sin hx equal to e raised to x plus e raised to minus x divided by e raised to x minus e raised to minus x. Sec hx equal to 1 divided by cos hx. So this is equal to 2 divided by e raised to x plus e raised to minus x. And cosec hx equal to 1 divided by sin hx equal to 2 divided by e raised to x minus e raised to minus x. So these are the definitions of hyperbolic functions. Likewise, we have formulas for hyperbolic function. Sin h of minus x equal to minus sin hx, and cos h of minus x equal to cos hx, similarly sin h of 2x equal to 2 into sin hx into cos hx. Okay, we have a very important identity for this function. Cos h square x minus sin h square x equal to 1. We are familiar with the identity of trigonometric function cos square theta plus sin square theta equal to 1. But here we have a slight difference between the trigonometric and hyperbolic function. The identity changes to like this: cos h square x minus sin h square x equal to 1. Okay, now friend, we discuss about the derivative of these functions. We find the derivative of these functions. So let us find one by one. As we have defined sin hx equal to e raised to x minus e raised to minus x divided by 2, then the derivative of this function d by dx of sin hx equal to d by dx of this term e raised to x minus e raised to minus x divided by 2, and we can write it as 1 by 2 into d by dx of e raised to x minus d by dx of e raised to minus x. This is equal to this 1 by 2 into, here derivative of e raised to x is again e raised to x minus derivative of e raised to minus x into minus 1 equal to minus minus become plus. So this is equal to e raised to x plus e raised to minus x divided by 2, and this is nothing but cos hx. Let us find the derivative of cos d by dx of cos hx equal to d by dx of e raised to x plus e raised to minus x divided by 2 equal to 1 by 2 into d by dx of e raised to x plus d by dx of e raised to minus x equal to 1 by 2 into derivative of e raised to x plus e raised to minus x into minus 1. So this is e raised to x minus e raised to minus x divided by 2, and this is nothing but sin hx. Okay, so friend, you know that derivative of cos theta equal to minus sin theta, but here you can see that derivative of cos hx equal to sin hx. So this is the slight difference in between trigonometric functions and hyperbolic functions. Derivative of sin hx equal to cos hx and derivative of cos hx equal to sin hx. So let us find derivative of one more functions, tan hx. So as you have seen, the derivative of sin hx equal to cos hx and derivative of cos hx equal to sin hx. I will write here derivative of sin hx here, d by dx of sin hx equal to cos hx and d by dx of cos hx equal to sin hx. So let us find d by dx of tan hx, d by dx of tan hx. Let us see the formula of term sin hx divided by cos hx. Now we apply the rule u by v. This is equal to derivative of first function v as it is cos hx into derivative of u. Derivative of u, this is cos hx minus sin hx into derivative of cos hx, that is sin hx divided by v square, that is cos h square x. This is equal to cos h square x minus sin h square x divided by cos h square x. This is an identity. This is equal to 1. So 1 divided by cos h square x and 1 divided by cos is nothing but sec h square x, and hence derivative of tan hx equal to sec h square x. Similarly, we can find the derivative of cot hx. Let us find the derivative of sec. Again we apply u by v rule. Friend, you can see that if we find the derivative of d by dx of sec hx, this is equal to d by dx of 1 divided by cos hx. This is equal to cos hx into derivative of 1, that is 0, minus 1 into derivative of cos hx, that is sin hx divided by cos h square x. This is equal to minus sin hx divided by cos hx into 1 divided by cos hx. I have written this cos hx as a 2 times. Okay, this is equal to minus tan hx into sec hx. So derivative of sec hx equal to minus tan hx into sec hx. So we have seen, friend, how to find the derivative of the hyperbolic functions and the definitions of the hyperbolic functions. Thank you, friends. Thank you for watching.